Okay, scholars, welcome back. So this lecture is going to be on right triangle trigonometry review, basically just reviewing all of the things that we've been talking about in class over the last few weeks, prepping for the quiz, which is going to be in a couple days. Okay, so the first problem I'm going to give you guys, I'm going to go quickly here. I'm going to number these problems. So if there's one particular problem you don't understand, then just come into class tomorrow and say, hey, Dr. Krieg, I wasn't sure about problem number 1, or could you do an example like problem number 4 again? Okay, so let's go through this super quickly. Okay, so the first problem I've got for you is here we've got a triangle and we've got some angle theta. Now, first thing about this triangle is you'll notice is I don't know what this third side is. So when I give you a problem like this, I'm going to ask you, okay, solve for the third side, solve for the missing side. It might be the hypotenuse, opposite, adjacent, either one, or any of them. Solve for the missing side and then give me the 6 trigonometric identities for the angle listed here. So the first thing you need to do is to notice that a squared plus b squared is equal to c squared. So in this case, a squared is going to be right here. B squared is going to be this 10 squared is going to be equal to 26 squared. Now I plug this into my calculator. I remember that 10 squared is 100. 26 squared a little bit trickier. That's going to be 676. Then I just subtract 100 from both sides, and I see that a squared is going to be equal to 676 minus 100, which is 576. A squared is going to be equal to 576. Now, if I square root both sides of this, I'll find that a is going to be equal to 24. Awesome. So a is equal to 24. Once I know that, I can easily do my SOHCAHTOA. Never ever forget SOHCAHTOA. Fantastic. So now once I've got SOHCAHTOA, I've got my missing side, I can easily figure out that the sine of theta is going to be equal to, so I'm looking from this angle right here, sine is going to be opposite over hypotenuse, which is going to be 10 over 26. Now I can reduce this down, pull a 2 out of both. This just becomes 5 over 13. When you're giving your answers, make sure you're giving your fully reduced answers. The other one, cosine of theta, is going to be adjacent over the hypotenuse, which in this case is 24 over 26, or 12 over 13 as it reduces. Now the tangent of theta is going to be opposite over the adjacent, which is going to be 10 over 24. Or once again, this will also reduce down to 5 over 12. So that's my first 3, sine, cosine, tangent. Now my other 3, of course, relate really closely. So the cosecant of theta, the secant of theta, and the cotangent of theta. Now, all I need to remember if I want to do this super quickly is that the cosecant is just the reciprocal of the sine. So here I've got 5 over 13. This one's going to be 13 over 5. Secant is reciprocal of cosine. Here I've got 12 over 13. This one's going to be 13 over 12. And the cotangent, reciprocal of the tangent. So tangent's 5 over 12. Cotangent's going to be 12 over 5. Just like that. Here's the missing side. Here's the 6 trig identities. Done. Just like that. Nice and easy. Now problem number 2. Problem number 2, I need to remember what my 30, 60, 90 triangle is. And so I'm going to start off with just by saying 1, 2, square root of 3 are going to be my sides. This one is going to be 30. This one is going to be 60 degrees. And the problem I'm going to give you guys is the cosine of pi over 3 times the secant of pi over 3 minus the cotangent of pi over 3. Now this one, a lot of them that we've been doing have been giving us different angles. This one, we can see every single angle is pi over 3. This may not be as simple on the test. First thing I need to figure out is pi over 3, and we'll change this to degrees to make it a little bit easier on me. So I multiply by 180 and I divide by pi. The pi's cancel. 180 divided by 3 is just going to be 60 degrees. So the first thing I need to find is the cosine of 60 degrees. So I'm at my 60 degrees. I remember from SOHCAHTOA, cosine is the adjacent over the hypotenuse. And, the adjacent over the hypotenuse. So the cosine of 60 degrees is just going to be equal to 1, which is my adjacent, over my hypotenuse, which is 2. Now the secant of 60 degrees This is just going to be equal to, if I remember, the secant is just 1 over the cosine. 1 over the cosine. Well, or the reciprocal of the cosine. So I know the cosine is 1 over 2 at 60 degrees. So the secant of 60 degrees is going to be 2 over 1, which I can just, not simplify down to 2. Not simplify down to 1, but simplify down to 2. Now the last one is the cotangent. Cotangent of 60 degrees. Cotangent of 60 degrees, remember, if the tangent is the opposite over the adjacent, so I can figure out what the tangent is. So a tangent is going to be root 3 over 1. Just do a sidebar here real quick. Tangent of 60 is going to be root 3 over 1. So then the cotangent is going to be 1 over root 3, that reciprocal. Now, of course, I can't have a radical on the bottom, so I have to do root 3 over, multiply the whole thing by root 3 over root 3. So the whole cotangent of 60 is going to be root 3 over 3. So now I've got my 3, cosine of 60, secant of 60, and the cotangent of 60. So when I'm going back up here to my original equation, I say the cosine of pi over 3 is going to be 1/2. Now the secant of pi over 3 is going to be 2, and the cotangent of pi over 3 is going to be root 3 over 3. So I've got 1/2 times 2 minus root 3 over 3 is going to be equal to, this is just 1/2 times 2, 1, minus root 3 over 3. Fantastic. Now this is going to get me 4 out of 5 points on the quiz, but of course we want to get 5 out of 5. We also want to impress all of our college professors. So we need to simplify this fully. In order to do that, I need to combine these sort of whole number and this fraction right here. So if I rewrite the 1, I need a denominator of 3, so I can rewrite the 1 as 3 over 3 minus, and then I say root 3 over 3. And so the whole answer, the whole thing is going to be divided by 3. Then I just combine the top. On the top I've got 3 minus, and then it's root 3. Once again, I know this looks like I can simplify it, but I can't because of this tricky radical right here. It's kind of throwing everything off. So this is going to be the answer that's going to impress all my college professors and is going to give me 5 out of 5 for that problem. Now problem number 3, we're talking about the cofunctions. We were just doing this the other day. So problem number 3 is, I'm going to give you 3 quick problems. So remember that the cosine of 54 degrees, I'm looking for the cofunction or the opposite expression that's equal to this. So the cosine of 54 degrees, cosine turns into the sine. That's my first step. And then this 54 degrees, it's not going to be 54, but because I'm doing the cofunction, it's going to be 90 minus 54. So this just becomes 90 minus 54 is 36. So then I know that cosine of 54 degrees is also equal to the sine of 36 degrees. Done. Okay, problem B. Another one. This one, I'm looking at the secant of 27 degrees. I'm going to follow the same steps. Remember the secant, secant is 1 over the cosine, so then it's just going to become 1 over the sine, which is a cosecant. Then I'm going to do the same thing here. So instead of 90 minus 54, here I've got 90 minus 27, following that second step. Now this just becomes the cosecant of 90 minus 27 is 63 degrees. Now the last one is going to be a little bit trickier, but you guys got this. Let me readjust some things here. Okay, so here's going to be the cotangent of pi divided by 8. Now first let me set this up. The cotangent, the opposite of this, or the cofunction of this, is just going to become the tangent. And instead of, so here I've got radians, so I know my answer needs to be in radians. Remember, there's 2 ways to do this. One is you can convert it to degrees and then do the 90 minus and then convert it back into radians. Or you can just do the whole thing in radians with some fractions. So 90 degrees in radians is pi over 2. And then here, so instead of 90 minus my degrees, I'm going to have pi over 2 minus my radians, which is pi divided by 8. Now let me sidebar here real quick what this is. So I've got pi over 2 minus pi over 8. So I need common denominators, so I multiply the top by 4 and the bottom by 4. And then this just becomes 4 pi divided by 8 minus pi divided by 8. Running out of room here a little bit, but this is just going to become 4 pi minus pi is going to be 3 pi. And the whole bottom is just going to be 8. Fantastic. So this whole thing right here, my cotangent of pi over 8 becomes my tangent of not just pi over 2 minus pi over 8, but we can simplify that, rewrite it as 3 pi divided by 8. Once again, 100% correct answers right here, impressing my college professors. Awesome. Problem number 3, done. Let's move on. Problem number 4. Problem number 4, getting a little bit trickier, but not too much. Just once again applying SOHCAHTOA. So here I give you an angle, 37 degrees, and I give you a length, 250 centimeters. That's going to be this edge right here. And then the height right here is going to be A. So I'm going to go with my SOHCAHTOA. And in this case, I'm asked to find what is this length right here, what is A. So I look at what I've got. I've got an angle, so I know theta is going to be 37 degrees. And I've got my adjacent angle right here, or my adjacent length right here, and I'm looking for my opposite. I know it's labeled with an A, but it's the opposite of the angle right here. So I've got an opposite, and I'm looking for an opposite. I've got an adjacent, so that tells me I'm going to use my tangent. So I can say the tangent of my theta, which is going to be 37, is going to be equal to A, opposite over adjacent. Opposite is my A, and my adjacent is 250. So if I multiply both sides by 250, then I get 250 times the tangent of 37 is going to be equal to A. Now when I'm doing this with my calculator, I need to make sure 100% that I'm in degrees and not in radians. So in order to do that on my calculator, I'll show you guys here. I've got a little degrees, a little DEG right there in the bottom of my screen, which is fantastic. If it wasn't radians, I would hit this DRG button, and I can see what pops up here. I can shift over to radians, or if I was in radians, I can shift back to degrees, hit enter, and then I'm going to have DEG or RAD over here. So if I plug in 250 times the tangent of 37, and I hit enter, I get 188.39. So then I know that A is going to be equal to 188.39. We haven't impressed our college professors yet because we are missing what? We're missing the units. We're looking for the height. In this case, it's centimeters. So this is measured in centimeters. Our units are going to be in centimeters. So our height is 188.39. Okay, problem number 5. This one is going to be deceptively simple. And it's basically just an exercise in using your calculator. So say I give you the cosine of theta is equal to 0.8771, and I want you to figure out what theta is in degrees. So in order to do this with my calculators, hopefully you guys have this one down. All I need to do, instead of typing the cosine, I use the inverse cosine, or cosine to the -1, or it's also called the arc cosine. So if I do the arc cosine of 0.8871, or sorry, the arc cosine of 0.8771, and I hit enter. Once again, remembering that I need to be in degrees, I find out that it's going to be 28.71 degrees. So theta is going to be equal to 28.71 degrees. I can also give you this problem and say, hey, find the cosine of theta is equal to 0.8771 in radians. So in this case, I'm just going to hit my DRG button, convert it over to radians, and then I can see I've got my same equation saved here, so all I need to do is push enter, and I get 0.501 radians. So theta is also equal to 0.501 rad. Now I can do the same thing. I can get the same exact answer if I take this 28.71 and I do the radian to degree conversion. Okay, last problem, number 6. This one is going to require me to illustrate my artistic abilities right here. So here we've got a tree, and you're looking for the height of the tree. Excellent. So using a right triangle, the tree is very conveniently casting sort of a shadow over here, and I know that the angle between the top of the tree and the end of the shadow, I know that this angle is 40 degrees. And I also know that the shadow is 35 feet long. Awesome. So the first thing I'm going to do is realize, hey, this problem's not that hard, this application problem. All I need to do is realize I've got a right triangle right here. I'm looking for H. And I've got my one side right here, 35 feet. And I've got my one angle here, which is 40 degrees. So once again, looking back to my SOHCAHTOA, this is really similar to the problem we just did in number 4. I realize I've got my adjacent, I need my opposite, and I have this angle. So that tells me that I need to use my tangent. So if I say the tangent of my angle, which is 40 degrees, is going to be equal to h, the height of the tree, which is the opposite, over the adjacent, which is 35 feet. So I'm going to do the same thing I did before, multiply both sides by 35, and I'm going to end up with 35, h is going to be equal to 35 tan of 40. Now if I put that in my calculator, check this out. 35 times the tangent of 40. Boom, I hit enter. I get negative 39.1. Well, this answer doesn't really make sense because it's a negative. So all of a sudden I'm sort of scratching my head. Then I realize, oh, I left my calculator in radians. So I'm going to go to my DRG button, put it back into degrees, hit enter, and sure enough I get 29.37 feet. Pardon me. So my h, making sure that I'm in degrees, is going to be 29.37, and make sure we're putting the units on there, impressing our college professors. 29.37 feet. Fantastic, seniors. That's all I've got for this review. Come tomorrow with questions. We'll do some practice problems, prepping you guys for the quiz. I'll see you then.